Humans are hardwired to crave snacks that deliver sensory crunch and physical volume. But to satisfy that evolutionary drive today, we usually reach for processed foods that pack enormous caloric density while offering almost zero actual nutrition. The moment you swallow those engineered snacks, your digestive system rapidly breaks down their simple carbohydrates, flooding your bloodstream with glucose. This chart shows exactly what happens next. Blood sugar levels over time form a sharp, violent spike into a red zone as glucose hits your system, triggering a massive insulin release. That insulin clears the glucose so aggressively that you experience a steep crash, dipping well below your baseline, a metabolic state your brain interprets as immediate starvation. Breaking this cycle requires a food source that provides the physical volume and crunch that satisfies our brain, but operates under an entirely different set of metabolic rules once it reaches the gut. This is Makhana, the foxnut, seed of the prickly water lily, an ancient structure harvested for centuries. By relying on the structural design of a raw seed rather than a lab-designed recipe, this plant-based architecture offers a way to navigate the metabolic pitfalls of modern snacking. The story begins in the shallow wetlands of Asia. Here, the Euryale ferox, or prickly water lily, breaks the surface of murky, dark water. This is a highly competitive, hostile aquatic environment. To ensure its lineage survives, the lily has to pack immense biological fuel and robust defensive compounds directly into its seeds. Extracting those seeds requires labor-intensive harvesting from the thick mud. Once retrieved, they are dried and heat-popped, transforming the raw aquatic plant into an edible, airy puff. The plant's relentless struggle to survive in a nutrient-poor wetland dictates the seed's dense, highly specific internal nutrient architecture. Zooming past the wetland environment and into the microscopic anatomy of the popped seed itself, that architecture becomes highly visible. Makhana holds an unusually high ratio of complex proteins to carbohydrates. It diverges sharply from conventional agricultural grains by prioritizing structural proteins over easily accessible starches. This diagram illustrates a microscopic cross-section of the Makhana seed. Those dense, interlocking structural fibers create severe mechanical difficulty for the human digestive tract, actively resisting rapid enzymatic breakdown. This chart shows the glycemic index. Plotting a potato chip creates a steep curve hitting the high GI red zone, but Makhana's fibrous matrix forces a metered energy release, drawing a flat, stable green line safely above the baseline over a much longer period. A slow, steady trickle of glucose requires only a slow, steady release of insulin, entirely avoiding the drastic spikes and crashes that trigger constant hunger. The seed effectively tricks human biology. It provides the physical satiation of a heavy snack alongside the microscopic metabolic footprint of a low-impact superfood. The macro matrix is only the first line of defense. Zooming down to the molecular level, we find chemical defenses originally deployed to protect the seed in the wild. To survive severe oxidative stress in the wetlands, the water lily produces camphorol, a highly potent antioxidant compound. In the human body, oxidative stress comes from free radicals, highly unstable molecules that damage cells, triggering systemic inflammation and accelerating cellular aging. This molecular model demonstrates how the plant's defense system functions inside us. A camphorol molecule structurally binds to a jagged, volatile free radical, instantly stabilizing it into a neutral, harmless shape. While the structural fiber pauses hunger, the camphorol actively alters cellular signaling to halt systemic inflammation right at the microscopic level. You extract sustained baseline energy from the complex macromatrix and active cellular protection from its microarsenal. The combined effect of these macro and micronutrients works to stabilize blood glucose and reduce systemic inflammation. It shifts the focus from merely counting calories to managing the body's internal chemical signals. Food conglomerates currently spend billions of dollars trying to synthetically engineer the exact satiety and health profiles that this aquatic plant perfected naturally in the mud. Makhana exists at a rare intersection where ancient agricultural tradition perfectly aligns with and validates cutting-edge nutritional science. As we rethink human nutrition, the evidence suggests that managing modern metabolic needs may rely less on laboratory innovations and more on the specific evolutionary architecture of the botanical world.